Hello, everyone. I am Marc Ballouz, the president of ISSMGE, with a new and exciting episode of IITT Interactive, International Interactive Technical Talk, bringing together people from industry, academia with experience, or young engineers from around the world. And this time, the topic is another exciting one of geotechnical engineers and their connection with megacities and the development of megacities and our responsibilities. Together, we have with us wonderful experts. I will start sharing my screen to introduce them. So, our famous Askar Zhussupbekov, and he's a professor of civil engineering and director of Geotechnical Institute of Eurasian National University in Astana. He is also the chair of TC305 on megacities. He's going to tell us about the missions and activities of this amazing technical committee and active technical committee. With us also Professor Ramanathan Ayothiraman. Hopefully I pronounced it right. A
Yes.
professor at the Institute of Technology in Tirupati, India. He's a member of TC305. He's going to tell us about the interaction of geotechnical infrastructure in megacities. And Dr. Rasin, he's now back to professorship after being in the industry, and I know him as a contractor, and that's amazing to come back and teach the students how to apply what they're studying. Professor at Istanbul, Jelisim University, and he's going to tell us about the sad earthquake that happened and the post-earthquake reconstruction progress. And from Russia, we have Dr. Elena Bragar. She's going to tell us, she's a professor at the Industrial University of Tyumen, Russia. The changes in the mechanical properties of clay soil under cyclic freezing and thawing. Welcome, all of you. And we're going to go and not waste time with our first speaker, Askar. The floor is yours. I will stop sharing. Please share your screen. I will be on mute. And you are all welcome to interrupt Askar. Or any speaker. It's an interactive talk, especially if you feel that the viewer may be asking this question that or to complement what everybody's saying. So I will be the moderator, and hopefully we can stay on track with time. Askar, the floor is yours.
So thank you, Marc Ballouz, our president, for giving to me opening of this very important TC305 interactive session. It is very nice because before we don't have such interactive session in our life in ICMGA. So Professor, our president, Ballouz Marc bring and brought very fresh wind from United States. So it is very, very nice for us for discussion, real academic and practitioner together with young generation also. So I will be informed about mission and activity very shortly because I am chairman now, but new chairman now already elected, Professor Lois Ge from National Taiwan University. 2026, 2030 will be new chairman. Also vice chairman, Professor
That
Hoylin,
was
but now is
yesterday.
yes,
Yes, that's
new
good
one. But
news.
anyway, we wait of website of our ICMG new name. So before coming new name, I am still chairman. So also vice chairman
Yes,
is
yes.
Professor Hoylin,
It's
but
a
new
good
vice
sign
chair
that
also Professor.
your technical committee is very active. I love it.
Yes. And new vice chair will be Professor Victor Kalyakin from University of Delaware from United States again. Secretary now, Louis Gay, changed from Professor Derwin, but now it's Louis Gay became to new chair. So this is a total member about 44, big number, big number, big number of very active number of TC305, increasing every time. This term of reference very shortly. So we disseminate our knowledge between practitioner academician and also for designing and practice of geotechnical technology in megacities, also new capitals. I am from new capitals, Astana. So you can see some activity in the down of objective one, object two, some guidelines and recommendations, establish guidance and technical recommendations for design and practice of geotechnical technologies at megacities and new capitals. Also, you can see conference assistance. We must be more joined with technical program of international and regional conference. So last our activity was in Australia. So we make some exhibition, not only some session. So we serious big exhibition was in Australia, in Sydney, and also objective for industrial links. So we must be good interaction with the industrial sector. So we have now very good interaction with the industrial sectors, including also company Kashtash. Maybe Professor Rasin remember his company, very nice company, and also another company like Keller, Solmek, and another company from Kazakhstan and Turkish. Activity very briefly. So we TC305 connection, also not only 305, also another technical committee like ITC 19, ITC team or Asian. But this is one of Joe Sakura conference together with Professor Iwasaki in Nara. One of biggest TC305 Asian regional conference was in Astana 2023 under the name Smart Cities for Smart Societies. So this is also more related with TC05. So you can see big number participated, about 700 people from 90 countries. So you can see this activity. Also, Professor Marc Ballouz, so you can see also a gift for our Bright Spark lecturer from Australia, and Blacks, also many active, like Professor from Bauer company, Professor Tom Bauer. Also, we interact with also Geosynthetic Society, not only ISSMGE conference, ISSMGE Society. It is Geosynthetic, our activity together with in Roma. So also we have good connection with the Chinese, because Chinese is very near with Kazakhstan. So we have also some connection, also more propaganda of our TC305 to China. So this is some activity in Kazakhstan, not only foreign country, also Kazakhstan. Also this Osaka Earthquake Engineering together. We also organize also in Russia. This is a house of architecture. We made together TC305. So this is also one of last United States Kazakh mini symposium. So 3 representatives from United States come to Astana and gave lecture. Anna Shidlovskaya and Kalyakin, also Dr. Raiha from Purdue University. So this is one of representatives received high-level awards from Japanese Geotechnical Society, from international collaboration with GIS, one of very strong Japanese Geotechnical Society. So this lecture in the Tokyo Institute of Technology, one of famous university in Japan. Also, we organized together with Xijian University in China, Hachinoki Institute of Technology in Japan, and Eurasian University joint workshop. So this is also some activity in Malaysia. So I want to also say last activity was in our activity was in St. Petersburg 1 week ago. We organized together with Russian Society and Geo Reconstructions University, Geo Reconstruction Company, and also Geostroy Company together TC305 session. So one professor from United States, Professor Kalyakin, gave very nice short course, 3 hours, by Russian language, not only English, but the Russian language. I surprised how is US professors can speak by Russian more better than Russian people. So this is also another propaganda. You know, we like propaganda for invite maybe you 4 person come to Moscow in March, Intelligence of Guard Mechanical Safety. So this second international scientific conference. Dr. Ballouz also participated Geomos 1, first Geomos in Moscow. Maybe he remember about this activity. And 10 years ago,
But
maybe,
in
more than 10
English,
years
in
ago.
English.
Yes, 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 yes.
That
By
was in
English, of
English.
course, by English. By English, of course. This time by English. So this is also some schedule about this to 2026 and also made on temps, and also you can connection also through me and also direction. So this direction to Moscow, this is some QR code and registration fee free of charge. So you can come, and because it's celebrated 95 years celebration of Moscow Research Foundation Institute, one of main institute in Russian Federation, also CIS countries regarding of geotechnical engineering. So this is my short information about our activity, our mission. So more mission, one of very big mission is connection with local governor, local Department of Civil Engineering. So each members TC305 try connection with the local government Department of Civil Engineering, because it is very important for scientific supervision of local geotechnical infrastructures of cities, especially for megacities, and also like Astana, new capital, because new capital now coming also from Indonesia, maybe you know, constructed new capital now. Also near Almaty, we constructed also new city, Alatau. So many countries now try solve of new capital because some problem of geo-environmental problem and also no space for developing. Now is Iran, maybe you know Tehran has some problem of water problem, so also one change of capital. So we must keeping our technology for construction, not only mega cities, also new capital. So thank you for your attention.
Askar, thank you. And keep this 305 running, even if you're not chairman. You can do you can do miracles. I've seen you. So I consider
Yes.
myself a very active president carrying the flambeau of geotechnical engineering around the world. And every time I reach a country, I find you there before me with the same.
No,
You're
I
so
preparation. I
active.
special coming before. I must preparation for you schedule that. It's important.
You are amazing. Thank you so much. The whole geotechnical community around the world is thanking you for this enthusiasm and, being so active. Raman, Professor, the floor is yours. Askar, if you unshare, please.
Yes.
Thank you, Professor Marc. Thank you. Is the screen visible?
Yes.
Okay. So, hello everyone, and I thank Professor Marc and Professor Askar for giving me this opportunity. And today I'm going to talk about interaction of geotechnical infrastructures in megacities. And this great initiative of International Interactive Technical Talk by ISSMGE is a wonderful initiative. I thank the President for having such a great initiative. And in today's presentation, I'll be covering under these headings, geotechnical infrastructure in megacities, and what are the challenges that we have while we execute these infrastructural work related to geotechnical engineering in urban areas. And of course, especially how the different geotechnical infrastructure interact in such a congested urban area. How do we assess their behavior and how do we mitigate the challenges? And I'll be just touching upon that. And of course, when we execute work in urban area, the safe construction practices, how important it is, especially in geotechnical work in congested area, and worker safety is our prime concern. And that is also, I'll just touch upon how it is important when we plan the geotechnical infrastructural work in the megacities. And of course, finally, I'll just summarize and discuss the way forward, which can be discussed in today's interactive session. We all know that the infrastructural developments are happening at a great rapid rate in megacities, and tall buildings are coming up, which are actually supported on either pile group or pile draft foundation. And transportation infrastructure is actually taking a great leap of growth. and which involves roads and large number of flyovers with reinforced earth walls, and the elevated metro corridors being constructed, and especially when we have space constraint, underground metro tunnels are significantly executed around the world. And one such example of project in India is shown here, Mumbai Metro, and which involves, of course, underground metro stations having a deep excavation of up to even 40-45 meter is a big challenge in a congested area, and we need to worry about it. And the vertical growth of space constraint in the above the ground now forcing us to go for larger basement, also up to 5-6 basements, and a lot of deep vertical storage tanks are also being used for storing waters and all in an urban area. So these are the major development that happens in urban, and which requires a lot of work related to geotechnical engineering. So coming to the challenges, what we face in work executed in urban area, or when we have tall buildings with basement which require deep excavation, and when we execute such a deep excavation of 40-45 meter of depth, definitely the safety of the existing buildings and the other heritage structures, monuments, which are very much important. And as a geotechnical engineer, we have the prime role to ensure that as a part of the execution of the work. And of course, a lot of space constraint, huge developments happen in urban area. Of course, there is a space constraint for the horizontal growth, and definitely they necessitate the underground tunnel constructions in a large way, actually. And of course, when we do construct tunneling in the underground, and which we will be running below several existing structures from utilities to tall buildings and other sensitive heritage structures, the risk assessment becomes very, very important. And that actually, governs the rate of underground tunnel constructions and the safety related issues. And of course, construction work carried out in an urban region is also going to pose challenges related to vibration and noise and other dust related activities because of the construction activities. And a lot of development happens by demolishing the old structures, and the new structures are built, and this leads to kind of a huge amount of construction and demolition waste to be handled also in an urban area. This is also one of the major challenges actually posed for the development happens in megacities. And today I'll be focusing mostly for the work related to metros and the other transportation mode. We know that the major public transport in urban is actually roadways and railways. We can see the rails are running in a viaduct, and the traffic, road traffic. So therefore, a lot of development required in mass rapid transit system involving subway or underground constructions and so on. But the major problems with roads of transport is, there is a huge traffic, and, especially countries like India where huge population is there, you can see a huge traffic congestion in the road, and public transport is too crowded. And especially when we have heavy rainfall and weather flood related issue, then this is what happens in road transport. This forces us to go for the metro rail projects, which is either elevated corridor or underground. And this slide shows the world metro figures. We can see China topping around, more than 10,000 kilometer running length of metro work already functioning. And India is currently having 1,035 kilometers, spread over 23 cities. And new projects have been already launched by India, targeting in next 3 to 4 years, India would like to be topping in second position with the total running kilometer length of metro rail projects. And this is the map showing the ongoing and already running metro projects in all over the country, 23 cities. And the left side figure shows the elevated metro is the yellow dots, and the red dots showing the metro involving underground tunneling works. And as I said, we have either elevated metro or underground metro. So today I'll be focusing the challenges and the interaction that is likely to happen because of the underground infrastructures. So we know that when we construct the metro tunnel underground for the transportation, it involves two tunnels actually. So the possible interaction is, the interaction of the second tunnel construction on the existing pre-constructed tunnel. So how they are going to interact? So what is the time lag with which we have to construct the second tunnel so that it is not going to affect the already installed tunnel? So this is one problem which definitely we are concerned. The other thing is, when we do the tunneling activity, so there will be existing structures that could be a masonry building, it could be RCC multi-storied building, or it could be a heritage structures, and it could be on the surface or underground. So one thing is, what is the effect of tunneling on the existing structures? So this problem has been there for many decades, and a lot of research have been done, and existing guidelines are there for assessing the safety of the existing structures due to the tunneling activity. But the reverse problem is actually something is going to be growing, because now we are actually building large number of tunnels. Let us say these tunnels are existing, and this tunnel alignment and the metro alignment becomes an important point of attraction. And a lot of new developments are likely to happen close to the existing metro routes. In that case, what happens due to the new construction activity to the existing tunnel? How do we ensure the safety of the running tunnels due to the new construction activity? On this problem, very limited studies have been actually carried out so far. And that is what our group would like to, highlight in today's interaction. And our group have been working over the last 10 years, actually. And of course, if these structures coming in a seismically active regions, that is earthquake prone region, their interaction under the earthquake load becomes, very, very pertinent. And this is the slide showing how, due to tunneling, the existing building will move towards it. And as a result, these piles have to be designed for additional kinematic forces due to soil movement. They will experience additional bending moment, deflection. For all these things, definitely the guidelines are actually, available, and different country codes are being followed, actually. So this is the picture showing the damages during tunneling, which was recorded way back in 1994 in Munich. And of course, even recent earthquake in Calcutta Metro, also the 2019, there was a damage occurred, actually. Whereas the reverse problem, what I said, that how do you ensure the tunnel safety due to the construction of new activities? Let us say this tunnel is existing. Now, when we do an excavation activity close to it, the tunnel is likely to move towards it. It will get oval shape like this. So this problem have been studied by a large number of people. Few of the recent work, classical work I have highlighted here. And whereas the other problem is that tunnel is existing here, and we do a lot of construction of the basement and multi-story building, and they will actually, whereas show a different pattern of deformation and strain in the lining, actually. So our group have been working on this problem, the second problem. And there are case studies of failures have been reported due to the construction of new activities on the tunnel. Way back in Furboard in 1988, the London subway tunnel collapsed due to the nearby excavation. And of course, there are case studies reported in Shanghai metro construction as well. The cracks and the spalling of the concrete lining and dislocation, such sort of failures happen on the existing tunnels due to the new construction activities. So our group have been carrying out, large scale model testing in the laboratory, simulating the actual tunneling process in the laboratory. And further, subsequently, we apply the load on the structural loading have been simulated like this. And we try to understand how this existing tunnel will deform and the strain developed in the lining, actually. So this figure shows how the tunnels are deforming when the tunnels are away from the building, actually. This horizontal axis shows the distance between the existing tunnel and the new construction activity. So closer this one, obviously, the tunnels are likely to deform more. And the Singapore guidelines, by Land Transport Authority and Building Department shows that, the deformation should not exceed 15 mm. And we see that when the tunnels are in the vicinity of new construction up to about 1.5 D, then the deformations are exceeding. So this tells us and what should be the number of story that we should build close to the tunnel alignment, so that the tunnels are not deforming excessively and not undergoing damage. So the building department should come up with such kind of restrictive guideline, that what should be the limiting number of story, so that the existing tunnels are, public facilities are not actually damaged. So
Raman,
yes, sir.
can you explain X and D? D is diameter of the
Yeah.
tunnel and X the
Uh,
distance, radial
X,
distance?
yes, sir. Very good, sir. Yeah, D is the diameter, as you rightly mentioned. X is the clear offset distance between the tunnel springing line and the raft edge, actually. So that shows the raft of the building and the tunnel, how they are
The
separated.
closest, yeah, the
Yeah,
closest
yeah,
point of the raft.
yeah, exactly. Yes. So as
So
we can see, yeah,
when the
please.
diameter is
When the
okay, I
distance
see.
between
So
the
when you
when the
are almost the same 1D or 2D,
yeah,
so you have to be more than 2D to be safe, basically,
exactly. And this is from the displacement point of
for the
view.
sum.
We
Yeah.
do have a criteria based on the strain in the concrete lining, because what happened, this will lead to a major spalling failure kind of thing, the displacement criteria. Whereas the strain may not have a spalling kind of failure in concrete lining, but they will start developing cracking. But if the lining start developing cracking because of the tensile strain, what happens subsequently, the moisture ingress will happen into the lining and they will start deteriorating the life of the concrete lining. So we have the critical offset distance, what should be maintained from the strain criteria point of view as well as displacement criteria point of view. And of course, we have done experiments in sand, experiment in submerged sand conditions, and we did recently conducted experiments in clay soil as well. And currently we are working up with coming up with the comprehensive guideline for actually, coming up with the critical distance, what is to be maintained. And if you are coming within 2D, then the number of stories have to be restricted basically. So that the building loads are limited, so that the displacement and strains are limited. Now, coming to the another aspect that we are, very much concerned is the, safe construction practice in urban areas. And this data shows that, the OSHA data, that fatality rate in cave-in failure is 15 times greater than any other construction accident. That means our deep excavation work in urban area is really a major concern. And the report of analysis shows that, either it is because the deep excavation support system is improperly used, or they were available but not in use, or many cases it is not available. We can see the global data saying that even 64% are actually not having any proper support system. And of course, we also collected the recent data of 2024, because the previous one was in 2003. Even in 2024, we can see that the fatal injuries, predominantly due to, your excavation related failure. We can see around 80% of the fatal injuries are because of the excavation related issues. Even non-fatal injuries are actually about, close to on an average of 80-85% are actually due to excavation. So it still shows that even after decades of experience, we are still have to, learn how to execute the deep excavation works in urban area. And we have a lot to learn from the previous works and failures, and we need to definitely improve our engineering design as well as the construction practice, ensuring the safety. And the data shows that these are the probably the major reasons and attributing factors for the excavation failures in urban areas. And either the soil properties were not properly interpreted and used, or there could be a variation in the soil boundaries, which were not captured in the site investigation appropriately. And of course, the groundwater table was not assessed, dewatering, is not properly designed, and like that, several other minor factors are there. But the major factors you can see leading to the improper, capturing of the geotechnical profile, and improper interpretation of the design soil properties, and the groundwater has been another, third primary factor.
As
And to summarize, yeah,
as
yes,
a as an expert, I want to call myself, it's okay, in deep excavations and short deep excavation. I would put groundwater close to 60%.
yeah,
A
true, very, very,
groundwater
very
that
well.
hasn't been detected, which is the same as soil boundaries because it affects the soil and soil properties. So if you take the first three big slices, that's 60%.
Very well
But
said.
water, man,
Yeah,
I've done so many excavations. It's,
absolutely,
you know,
Professor.
and
Well
I
said.
investigated, and Rasin probably would know. Water, even a small pipe, broken pipe near the neighbors will lead to catastrophic events.
Yeah,
Anyways,
well said. Well said. True, very much
keep
true.
going.
Yeah, yeah. In the last slide, yes. So just to summarize, yes, the building damage assessment, existing building conditions have to be assessed in the pre-construction phase of the tunneling. And during construction, we have to monitor the sensitive structures. And of course, post-construction also, we have to assess to, handle the liability issues. And of course, monitoring is one of the important thing we have to emphasize. And of course, we have improved a lot compared to, a couple of decades back. And there is definitely scope for further, improvement in the practice of monitoring. And very good quality and appropriate site investigation is required, especially when we do the deep excavation work and tunneling work. And there are challenges in executing the site investigation. It is understandable because the existing buildings are there, whereas tunnel alignment is below the existing building. And we have to have an integrated approach of geophysical and other drilling techniques, finally a coupled investigation, integrated scheme. We have to use it, and the modern techniques like BIM technique and other thing have to be used in order to do a sound interpretation. And one thing I would like to highlight here, the involvement of the consultant, geotechnical consultant, I've seen, especially in India, comes at a later stage. I think if we start involving the design consultant and proof consultant from the geotechnical in the way beginning, from the beginning, this planning of proper site investigation and all those things can be handled nice, and many failures and the problems, can be avoided actually. And of course, there is definitely a need for coming up with the guidelines for tunnel safety, especially after the execution of the metro tunnels, any new construction, what should be the, safety guidelines, and which critical sections of existing tunnels need to be monitored whenever any new construction activity happens adjacent to the tunnel. All those things, we need to definitely come up with some guideline. And of course, the guidelines, protocols for guidelines for the safety of the workers and other things, we need to definitely improve. And the experience of failures and also the geotechnical data, we should probably put it as a repositories. And of course, whatever the copyright issues and non-disclosure agreement, their sharing policies need to be worked out. But the global data repositories will definitely help us, the geotechnical engineers, to learn from our things, sir. So thank you. Thank you for listening, and I will be happy to take discussion. Thank you very much. Sorry,
No,
I might
no,
have exceeded a
excellent.
few minutes late. Yeah, thank you.
Great summary, great summary. Rasin, we're so eager to know what happened after that deadly earthquake in Syria and Turkey, man.
Thank you, Mark. It's a pleasure to be part of this interactive technical talk. Today, I would like to present an overview of the post-earthquake activities, reconstruction activities in Turkey. So, the program 6 February 2023 earthquake general overview, affected provinces and collapsed and or heavily damaged buildings, construction of new settlements, and key takeaways. 6 February 2023 earthquake, a moment magnitude of 7.7 occurred in Turkey. Following the first earthquake, approximately 9 hours later, a moment magnitude of 7.6 earthquake struck the region again. These earthquakes were among the most destructive earthquakes experienced in Turkey in the last century. Unlike the previous earthquakes, for which the damage has usually concentrated in a certain city, the building damage spread to 11 cities. Both earthquakes took place on the East Anatolian Fault Zone, one of the Turkey's two major active fault systems. Based on the historical data, fault segments ruptured during the earthquake sequence were seismic gaps with tectonic stress accumulating for at least 500 years. Based on the maximum horizontal peak ground acceleration recorded at certain stations near the fault lines during the earthquake, building in 4 cities, Gaziantep, Hatay, Kahramanmaraş, and Adıyaman, were subjected to seismic actions exceeding in the Turkish earthquake code design levels. This is the table showing moderate and heavy damage buildings by province. Based on the building damage inventory, 5 cities, namely Hatay, Kahramanmaraş, Gaziantep, Adıyaman, and Malatya, experienced extensive damage due to their proximity to active fault lines, whereas the number of collapsed buildings in the remaining 6 cities was comparatively lower. Now, immediately after the earthquake, the construction starts. The reconstruction starts in 11 provinces. This under the coordination of Ministry of Environment, Urbanization, and Climate Change to replace the collapsed building across 11 regions. Following the completion of the site selection and geotechnical investigation, large-scale construction works commenced. These activities are currently ongoing across 11 regions, encompassing 174 projects and 3,481 construction sites, with the involvement of approximately 200,000 architects, engineers, and construction workers. The scale of the destruction was unprecedented, with estimated of 100 million cubic meters of debris, actually. The sustainable waste and debris management was identified as the critical engineering and environmental priority following the earthquakes. The earthquake generated an estimated 100 million cubic meter of debris, necessitating large-scale technical planning and environmental control. For that reason, 2 pilot debris management and recycling facilities were established in Hatay and Kahramanmaraş to address these challenges. Sorry. As you see in the picture, modern houses and Turkey's first rural satellite city construction start in the earthquake-affected region. Modern and resilient village homes have been built for citizens. Work continues in 4,303 villages. So far, 51,281 village homes have been delivered across by the region. And by the end of this year, it's planned to be completed.
Professor Rasin, may I ask one question?
Sure.
Yeah. So in the previous slide, you mentioned that large amount of waste have been handled, and so how much have it been reused in the new revised construction scheme? How much it has been reused actually?
Actually, I don't have exact figure for that, but I know these rubbles used in the construction concrete producing for concrete, but I don't have the exact figure actually.
Yeah, but it has been reused partly.
Yes, this is for reuse.
Wonderful. Thank you.
Thank you. Now, delivery status across the earthquake region as of October 2025. Almost 286 and 708 residential units, 12,189 commercial units, 51 2081 village houses, and total delivered 350,178 independent units. This is for not the whole building. It means independent units by like flats.
That's a huge thing to do, man.
Yes, yes. Almost 80% completed, Mark. So I think at
And
the
all
first quarter.
from Turkish companies and money from like who helped with the money? Was it the European?
There's a World Bank
community or-
fund actually, $1.7 billion, but of course Turkey government also finance it because it's very huge project in 11 cities and very rush project.
Yeah,
So the people
were these all done to resist future earthquakes?
Yes, sure, yes.
yes, Professor Marc, I was about to ask the same question. I think
Yeah,
his
it's actually
his acceleration
Because
data
it
has
will
shown,
cost 20 to 30% more to resist big earthquakes.
because as I mentioned before, the earthquake exceeded design level of Turkish code, earthquake code. So for each site specific earthquake investigation, site specific acceleration determined.
I live in Beirut on floor number 15, and I was shaking like crazy.
Yeah.
During that, the second day actually more than the first day.
Okay, even in Egypt, the
aftershock was crazy. Many people were so afraid here.
Terrible earthquake, yes.
We are neighbors.
So Rasin Bey, thank you. So Rasin, Dr. Rasin. So my question is 3,500 construction sites. It's very big number, very biggest number. So only Turkish company work or some foreign
only
also
Turkish companies, only Turkish companies. As a result, we cannot find any laborers in Istanbul and big cities. There's lack of laborers, steel fixers, carpenters, and crane operators, tower crane operators. So
Askar, these are independent units, not size. So you can have one site with 20 units, like the buildings you see in the picture.
Anyway, it is very big job because I think is for this job, maybe some foreign company also can come. But anyway, Turkish many strong, I think, company also.
Oh, we have a lot of companies in Turkey to do this such jobs.
They came from all over Turkey.
Yes, all over Turkey, from all over Turkey.
And do you know if Turkish companies were involved in reconstructions in Syria, or you don't know?
I don't know actually.
Turkish company very strong. He recovery after Second War, recovery of West Europe, German, etc. Also, is after revolution, and is Russian Yeltsin time. Also make White House. Also Turkish company.
Yes.
Also New Capital Astana. Also many Turkish company work. So Turkish company very strong, I think. Construction.
Yeah, many Turkish companies, they're experienced. The laborers also, the skilled laborers, they're experienced people. But if we quality control everything good, so there is no problem. Anyhow, I think it's almost finished. Yes.
Yeah, sorry. Please go ahead. Yeah. So I had a similar question like what Professor Marc asked. I mean, what is the design magnitude of the earthquake and the PGA? Because your acceleration time history you have shown in one of the slide, which reaches more than 1 G. I mean, so close to 0.98 G, 1 G. So now these buildings have been designed for almost for 1 G, or?
I think the 1 G recorded close to fault lines. The stations very close to fault lines. Now this for this buildings, of course, the location, selection of the location is important. So they select locations far from the fault lines.
Okay.
But of course, there is no change in the Turkish code for the design levels, acceleration, peak ground acceleration design levels. But I asked the same question to ministry engineers, what you have done, to how you design these buildings structures. So they mentioned that they performed site-specific ground acceleration, peak ground acceleration, to determine if they exceed or not. If they not exceed, they use the same ground acceleration in the Turkish code now.
Yeah, I'm also curious to know. Yeah, thank you. Thank you very much. I'm also curious to know what is the foundation used in supporting these buildings and what kind of soil you predominantly have there actually.
Generally, raft foundation were used in as a foundation system, and I don't have detailed information for the soil conditions, but as far as I understand, they try to be away from the flat places and go to hilly places. So at least over consolidated soils or rock, I believe. I hope. I want because I don't have detailed information. I couldn't reach detailed information about this subject.
Thank you, Professor Rasin.
You're welcome.
Thank you very much.
Thank you. You have more slides?
The last slide. Okay.
Take away.
More than 660,000 housing units suffered moderate or greater damage. Rapid large-scale reconstruction across the region. Of course, strong coordination and technical workforce mobilization. Currently, 200,000 architects, engineering, and construction staff are engaged in the construction sites. Approximately 100 million cubic meters of earthquake debris were managed safely and sustainably through the engineering and environmental-driven recycling strategies. As of October 2025, total delivered 178,000 units, and expected to be delivered 859 residential units, 31,307 commercial units, and 62,817 village houses at the end of 2025. This is the official number given provided by the ministry, but I think it will be delayed to first quarter, at the end of the first quarter of 2026.
Rasin,
thank you very much.
Do you know what was the official number of casualties or the real one? How many people
official
died?
53,000 officially.
Wow.
53,000 deaths and 130,000 injured, and 200,000 buildings were collapsed and heavily damaged. This is the figure,
Wow.
but we believe it's much more than these figures. That it's not official, of course.
God bless their soul.
Yeah, very sad.
Are you ready?
Thank you.
The floor is yours.
Okay, thank you. Okay, do you see my screen?
Yes.
Yes. Yeah.
Okay, I would like to present you my report under the title Changes in Mechanical Properties of Clay Soils under Cycle Freezing Solving. And in many parts of the world, from the vast expanses of Siberia and Kazakhstan to the northern territories of Canada and Alaska, soils are subjected to repeated freezing and thawing cycles. The natural process significantly alters the physical and mechanical properties of soils, leading to serious challenges in civil and geotechnical engineering. The practical impact is substantial. Every year, infrastructure such as building foundation, road maintenance, dams, and pipelines experience deformation, settlements, and even failure due to seasonal frost action. This not only compromises safety but also results in considerable economic costs for maintenance and repair. The findings are especially relevant for engineering projects involving foundations, transport roads, hydraulic structures, and energy infrastructure in these zones. The core objective of this work is to develop reliable predictive models that can help engineers account for these changes during the design and maintenance phases, ultimately contributing to safer and more durable construction in frost-affected regions. In the framework of the present study, a three-factor, three-level experiment was conducted, where the number of free-zone cycles, soil moisture content, and void ratio were selected as the main factors. Twin samples were prepared according to GO standards with specified moisture content and density in metal rings. The samples were subjected to 0, 1, 3, 5, or 10 freezing thawing cycles in closed system, with freezing at -20 points degree and thawing at +20 points degree, each lasting 12 hours. Direct shear tests were conducted to determine the soil strength parameters, and odometer tests were performed to determine the elastic modulus in accordance with Russian standards. A program was developed to mathematically process the laboratory data, taking into account all three factors. This program offers three methods to processing the experimental data: product, sum, and Taylor serial expansion. It was established that the maximum change in elastic modulus occurs within the first 3 cycles. With further cycle up to 10 cycles, the elastic modulus gradually stabilizes. Importantly, the change in elastic modulus directly depends on the change in specimen volume. Due to compaction during cycling freezing thawing, the diametric elastic modulus increases by up to 32%. Further data processing was performed using the developed program. Based on the processing of laboratory results, a dependency was derived using polynomial decomposition via Taylor series expansion. The change in internal friction angle due to cyclic freezing thawing is not obvious. During the first 5 cycles, both increases and decreases were observed. However, after 10 cycles, the internal friction angle either returned to its initial value or increases by up to 1.5 times for most loams. Thus, polynomial expansion via Taylor series is considered the most accurate of the methods examined and the recommended for engineering applications. Hagasian shows a clear decreasing trend, dropping by up to 80% due to cyclic freezing thawing. An exception is soft plastic loam, where Hagasian increased nearly threefold. Experimental theoretical dependencies for Hagasian changes were determined for medium hard loams and stiff loams using the product method, and for plastic loams using Taylor series expansion. To apply the findings of the study in engineering practice, the following algorithm was proposed for determining the physical and mechanical properties of loams under cycling freezing thawing. The first step is to perform a technical calculation to determine the depth of seasonal freezing and the number of freezing thawing cycles. The second step is to recalculate the physical and mechanical properties using results of the study. And the third step is to perform verification calculations for foundation deformations, slope stability, and so on. Thank you for attention.
Elena, thank you for this presentation about thawing and freezing. Are you in a permafrost zone?
Yes, I think that Russia maybe mostly is in permafrost zone, so it's really important research in our region.
Are you working on freezing, artificially freezing for stabilization, for tunneling, or what is your work on now?
No, I study only zone seasonally freezing thawing because in our city, so I live in Human, we don't have underground structures, so only so.
Above ground.
Enough space in Russia, right? Big territory.
Open fields. Good, good. So
Yeah,
guys, thank you very much for this session, exciting one. I want
Thank
to, congratulate you for doing great job and volunteering, and wish you all happy holidays. And this session will be on our channel in maybe 1 week or two, but we'll let you know, and we will broadcast it on LinkedIn and all our other social media and website. Thank you very much, and wish you a great evening wherever you are.
Thank you.
Bye-bye. See you
Thank you,
soon.
Professor Marc, and thank you, Professor Askar. Thank you, Rasin. Thank you, Professor
Thank
Elena.
you.
Nice
Ayothiraman.
meeting you all. Thank you very much. Thank you.
Professor
And
Askar,
wish you
bye-bye.
all Merry
Elena,
Christmas in advance and advance Happy New Year. Thank you.
Happy
Have a
New
great-
Year.
Yeah.
Merry
Marc,
Christmas.
thank you.
Merry
Bye-bye.
Christmas.
Thank
Happy
you.
New Year.
Thank you.